So in this video, I would like to explain worksheet questions of atomic structure. So here I have selected some important models. We will discuss one by one. First question, choose the correct statements in reference to photoelectric effect. So we know photoelectric effect, that is the ejection of electrons from the surface of metal when a suitable frequency, light of suitable frequency falls on it. So what is photoelectric effect? Ejection of electrons from the surface of a suitable metal when a light of certain frequency falls on it. So here see first statement. So there is no time lag between striking of light and ejection of electrons from the metal surface. So this is true statement. Why? Because there will be no time lag between striking of light and emission of electrons. So as soon as a light of suitable frequency touches the metal surface, electrons are ejected immediately. Therefore, statement 1 is correct. I will mark this one. Statement 1 is correct. Next, statement 2. See, number of electrons ejected is independent of intensity of light. So we know from photoelectric effect, number of photoelectrons emitted directly proportional to intensity of light. But here in statement 2, it is given number of electrons ejected is independent of intensity of light. Therefore, second statement is wrong. Next, see third statement. The elements potassium, rubidium, cesium can show photoelectric effect when exposed to beam of light. So here we know alkali metals, that means first A group elements. Alkali metals can show photoelectric effect. So why these elements are exhibiting photoelectric effect? Due to low ionization energy. Low ionization energy or low ionization enthalpy values. So here statement 1 is correct and statement 3 is correct. Therefore, so key will be B. B is correct. So these three statements are related to photoelectric effect. So which is most important topic. Second question. The approximate ratio of speed of light in vacuum to that of an electron in first Bohr orbit of hydrogen atom is. So here what is given? So speed of light in vacuum. We know speed of light in vacuum means c, velocity of light. That is 3 into 10 power 8 meters per second or meter second inverse. Next, velocity of electron in nth orbit 2.188 into 10 power 8 into Z by N centimeters per second in CGS system. Or we can write 2.188 into 10 power 6 into Z by N meters per second. So first one, velocity of light in vacuum, and the second one is velocity of electron in nth orbit. Here for hydrogen atom, we can write atomic number equal to 1 and first Bohr orbit n equal to 1. So therefore velocity of electron in nth orbit equal to 2.188 into 10 power 6 meters per second. So here we have to calculate ratio between these two. Velocity of light in vacuum to that of velocity of electron in nth orbit, that is 3 into 10 power 8 meters per second divided by 2.188 into 10 power 6 meters per second. So we'll get this value as 1.37 into 10 square, which is nothing but 137. That is velocity of light in vacuum is to velocity of electron in nth orbit will be 137 is to 1. Therefore, B is the answer. Ratio between speed of light in vacuum to that of velocity of electron in nth orbit. In nth orbit means here we have to take first orbit of hydrogen atom. For hydrogen atom, atomic number is 1 and orbit number also 1. Next question. When a radiation of 300 nanometers is shined on 5 metals, lithium, magnesium, silver, copper and potassium, the number of metals which can show photoelectric effect are. Which metals can show photoelectric effect? The metals which are having low ionization energy values can show photoelectric effect. So here lithium, magnesium and potassium are having low ionization energy values when compared to remaining two elements, that is silver and copper. Therefore, these three elements can exhibit photoelectric effect. Here we have to compare ionization energy. So among lithium, magnesium, silver, copper and potassium, lithium, magnesium, potassium have low ionization energy values. Therefore, they can eject electrons from their surface. Therefore, answer will be 3. 3 metals can show photoelectric effect. Here we can add one more point. Lithium, magnesium, potassium belong to S block. Silver and copper belong to D block. S block elements will be having low ionization energy when compared to D block. In this way, you can compare. Next. The orbital angular momentum of electron in 3D orbital. The orbital angular momentum of an electron in d orbital. So what is orbital? Angular momentum. It can be calculated by using root over L into L plus 1 into H by 2 pi. If L equal to 0, S subshell or S orbital, L equal to 1, P subshell, L equal to 2, D subshell, L equal to 3, F subshell. So here d orbital is given. For d orbital or d subshell, L equal to 2. So therefore, orbital angular momentum will be equal to, so root over 2 into, for d orbital L equal to 2, 2 into 2 plus 1 into h by 2 pi. So which is equal to 3 into 2, root 6. In place of h by 2 pi, we can write h bar. Since h by 2 pi equal to h bar, it is constant. So in options, it will be h bar. H bar. H bar is h by 2 pi. It is constant. So calculation of angular momentum is also very, very important. So key will be C option. It should be h bar. Next question. A microscope using approximate or appropriate photons is engaged to track an electron in an atom within a distance of 0.001 nanometers. What will be the uncertainty involved in measuring its velocity? So this is related to Heisenberg uncertainty principle. Here given value, uncertainty in position delta x is given. So which is 0.001 nanometers, that is equal to 0.001 into 10 power minus 9 meters in assay system. Next. So we know delta x into delta p equal to h by 4 pi, or delta x into m delta v equal to h by 4 pi, or delta v equal to h by 4 pi into m delta x. This is the formula for given question. So therefore, delta v equal to, what is h value? H value, 6.625 into 10 power minus 34 joule into second, divided by 4 into pi value 3.14. You can take m value, mass of electron you must take 9.1 into 10 power minus 31 kg into delta x. So 10 power minus 3, 10 power minus 10, 10 power minus 12 meters, and then 10 power minus 12. Therefore, delta v equal to, finally we'll get value 0.0579 into 10 power 9 meters per second, or we can write 5.79 into 10 power 7 meters per second. This will be the answer. So 5.79 into 10 power 7 meters per second. So option will be A. So this is Heisenberg uncertainty principle. So uncertainty in position is given. We are calculating uncertainty in velocity. Direct formula. Next question. Number of radial nodes in 3s and 2p orbitals. 3s and 2p orbitals respectively. Here, number of radial nodes equal to n minus l minus 1. So what is n? Principal quantum number. L azimuthal quantum number. So based on principal quantum number and azimuthal quantum number, we can calculate number of radial nodes or simply nodes. So here for 3s. Next one more point here. L equal to 0 for S subshell. L equal to 1 for P subshell. L equal to 2 for D subshell. L equal to 3 for F subshell. Remember these. So here 3 represents n value. So therefore n minus L minus 1 equal to 3 minus 0 minus 1. 3 minus 1 2. Next for 2p subshell or 2p orbital, n equal to 2, n minus L minus 1 equal to 2 minus 1 minus 1, which is 0. So 2 0 is the answer. That is option B. Next question. In two elements, here two elements are given A, Z1, M1 and B, Z2 and M2. So where Z is atomic number and M is M or A we can take. M is mass number. Z is atomic number, M is mass number, or we can take atomic weight also. So here given M1 not equal to M2, Z1 not equal to Z2, but M1 given M1 minus Z1 equal to M2 minus Z2. So what is the meaning of M1 minus Z1? That means mass number minus atomic number. Here it gives number of neutrons. Number of neutrons. Here number of neutrons will be same in two elements. Therefore, A and B elements are isotones. So what are isotones? Atoms of different elements with the same number of neutrons. Isotones are the atoms of different elements with the same number of neutrons. Therefore, elements A and B are isotones, or simply we can say isotonic. Relation between A and B is isotonic relationship. Therefore, option will be A, isotonic. A, B are the two atoms of different elements, two different elements. But here relationship is these two elements are having same number of neutrons. Therefore, isotones are isotonic. Next question. The degeneracy of the level of hydrogen atoms that contain the energy of minus RH by 16 is. Here we know what is the meaning of degeneracy. Degeneracy means orbitals having the same amount of energy. Orbitals with same amount of energy. So we know expression total energy of electron simply En is minus RH by n square. This is general form of energy of nth orbit or energy of electron in nth orbit. So compare this formula with given minus RH by 16, that is minus RH by, we can say 4 square. So that implies here n equal to 4. So fourth orbit is given. So in fourth orbit, for fourth orbit we have 4s, 4p, 4d and 4f subshells. 4s, 4p, 4d, 4f. In 4s we have only one orbital, 4p 3 orbitals, 4d 5 orbitals and 4f 7 orbitals. So all these orbitals are having the same amount of energy. Here one orbital, 3, 5 and 7. So therefore degeneracy of fourth orbit is equal to, so total 1 plus 3 plus 5 plus 7, which is equal to 16. 16 is the answer. Therefore option B. Very important topic. Degeneracy. Degenerate means orbitals with same amount of energy. So in fourth orbit we have 16 orbitals. These 16 orbitals will be having the same amount of energy. Therefore degeneracy of fourth orbit is 16. So fourth orbit means you can calculate 4 square. Fifth orbit means 5 square. Sixth orbit 6 square. Like you can calculate degeneracy. Here remember energy expression. Energy of nth orbit equal to minus RH by n square, where RH is Rydberg constant for hydrogen. N is orbit number. Related to hydrogen spectrum, two series of spectral lines of hydrogen atom which do not belong to infrared spectral region are. So we know in hydrogen spectrum we will be having these spectral series: Lyman, Balmer, Paschen, Brackett, Fund and Humphrey series. So these are different types of spectral series. So Lyman series of lines were observed in UV region, Balmer series of lines in visible region, Paschen near IR, middle IR, for IR, and last one also for IR. So here these series related to IR region and remaining to UV and visible. So two series which do not belong to IR region are, simply we can say D option, Lyman and Balmer. So remaining lines will be observed in IR region. So here one more point. In this direction, energy increases. Energy of any spectral line increases in this order, Humphrey to Lyman. So energy, or we can say frequency and wave number. Next, in this direction, wavelength of spectral line increases. These 2 points are important. From Lyman to Humphrey, wavelength increases. Humphrey to Lyman, energy, frequency and wave number increases. Lyman series and Balmer series of lines not found in IR region. Okay, next question. In photoelectric effect experiment, kinetic energy of an emitted electron is 1.986 into 10 power minus 19 joules. When a radiation of frequency 1.0 into 10 power 15 second inverse hits the metal. Next, what is threshold frequency of metal in second inverse or per second? Here Planck's constant is given as 6.62 into 10 power minus 34 joule into second. So this one simple question only. Here what is given? Given kinetic energy. Kinetic energy 1.986 into 10 power minus 19 joules. Next, frequency of incident light is given. So 1 into 10 power 15 means I am writing 10 power 15 second inverse. We must calculate threshold frequency. We must calculate. Next, from photoelectric equation we can write K equal to H into nu minus nu naught. So from this, nu minus nu naught equal to Ke by H. So what is Ke here? 1.986 into 10 power minus 19 by 6.62 into 10 power minus 34. So we'll get this value as 0.3 into 10 power 15 second inverse. Therefore, nu naught equal to nu minus 0.3 into 10 power 15. So nu is given. Nu is 10 power 15 minus 0.3 into 10 power 15. So this value will be 7 into 10 power 14 second inverse. This is the value. 7 into 10 power 14 means option A. Nu minus nu naught value 0.3 into 10 power 15. Therefore, nu naught will be equal to nu minus and obtained value 0.3 into 10 power 15. So 10 power 15 common, 1 minus 0.3, 1 minus 0.7, 0.7 into 10 power 15 or 7 into 10 power 14. 1 minus 0.3 means 0.7. This question is related to photoelectric effect. Next one. Which of the following corresponds to the energy of possible excited state of hydrogen? So we know energy of electron in nth orbit is minus 13.6 into Z square by n square electron volts per atom is fundamental equation. So here for hydrogen atom, Z equal to 1. Therefore, En equal to minus 13.6 by n square electron volts per atom. So in case of hydrogen, excited state will be the excited states are 2, 3, 4, 5 and so on. Here I am taking minimum value. Consider E2. E2 is first excited state. E1 is ground level. That means energy of ground level. E2 energy of first excited state. E3 energy of second excited state. E4 energy of third excited state, like that. So E2 minus 13.6 by n square, that is 2 square, minus 13.6 by 4, so which is minus 3.4 electron volts. This is the energy of excited state, possible excited state of hydrogen. So here option C. Remaining options not possible. So minus 13.6 is energy of ground state, that is E1. E2 is energy of first excited state. So possible value is minus 3.4. Next question. The radiation with maximum frequency is. So already I have given this concept in synopsis. I will write different types of electromagnetic radiation. Electromagnetic radiation contains cosmic rays, gamma rays, X-rays, UV, visible, IR, microwaves and radio waves. So in this direction, energy increases, energy, frequency and wave number. In this direction, wavelength increases. See, from this clearly the options are X-rays, radio waves, UV rays and IR rays. Maximum frequency. So frequency means here X-rays. So option A simply. This is nothing but electromagnetic spectrum. Electromagnetic spectrum. Remember this order. Okay, next question. radius of first orbit of Li2 plus is x angstrom units. Radius of third orbit of He plus in angstrom units will be. So very important. So first for radius of first orbit of, we know radius of nth orbit formula. Radius of nth orbit 0.529 into n square by z angstrom units. So apply for Li2 plus. So Li2 plus means atomic number 3 and first orbit n equal to 1. N is orbit number, z is atomic number. So therefore radius of first orbit means here I am taking R1 0.529 into n value 1, that is 1 square means 1 by 3, which is given as x angstrom units. Next for He plus z equal to 2 and third orbit is given n equal to 3, atomic number 2 and orbit number 3. So for this R3, so 0.529 into n square, n square means 3 square by z value 2. So I am considering here R3 by R1, R3 by R1. So this is expression 1 and this is expression 2. So R3 by R1 0.529 into 9 by 2 divided by 0.529 into 1 by 3. 529 will be cancelled. You get value 9 by 2 into 1 by 3 means 3 by 1. So which is 27 by 2. So here we have to calculate R3 value. 27 by 2 into R1. So here R1 is x angstrom units, that is 27 by 2 into x angstrom units. This will be the answer. So option D. So here angstrom units must be there in options. by 2 into x angstrom units. In question it is there in angstrom units. No need to write angstrom units in options. This is also important model. Relation between Li2 plus and He plus. Next question. The electrons are more likely to be found at the place we have to find, where the probability of finding electron is maximum. See here in graph, here this is A and C. So here at A is peak or maximum. Peak or maximum. Here C also peak or maximum. So at peak level there will be maximum probability of finding electron. Therefore in given graph we can find electron at A and C. A and C. That means option will be B. So observe the graph. At A and C, there is maximum probability of finding electron. So what about B? B is node or nucleus, we can say. Nucleus. Probability of finding electron is 0. At A and C, there is maximum probability of finding electron. Therefore, we can find the position of electron at A and C to maximum extent. We will add here at peak or maximum, electron density will be maximum. So what are peak positions? A and C. Therefore, we can find electron at A and C only. Next one. Maximum number of electrons possible with spin quantum number plus half with principal quantum number 4. Principal quantum number 4 means fourth orbit is given. For fourth orbit. So how many orbitals will be present? For fourth orbit, number of orbitals equal to, here n equal to 4 is given, n square, that is 4 square, 16 orbitals will be there. Next, maximum number of electrons equal to 2n square, means 2 into 16, that is 32. So total number of electrons will be 32. In 32 electrons, 16 electrons will be having plus of spin and remaining 16 electrons will be minus half spin. Therefore, answer A. 16 electrons are having spin plus half. The remaining 16 minus half. Here in question it is given principal quantum number n equal to 4, that is fourth orbit. In fourth orbit we will be having 16 orbitals and 32 electrons. 16 orbitals can accommodate maximum of 32 electrons. Out of 32 electrons, 16 electrons will be having plus of, that means clockwise spin. Remaining 16 electrons will be having anti-clockwise spin. Next. Maximum number of electrons present in an orbital with n equal to 4, L equal to 3. Given principal quantum number n equal to 4 and azimuthal quantum number L equal to 3. So we know L equal to 0, S subshell, L equal to 1, P subshell, L equal to 2, D subshell, L equal to 3, F subshell. So therefore, based on given data, the subshell is 4F subshell. 4F subshell. Then how many electrons will be there in 4F subshell? So you know the maximum number of electrons in subshell equal to 4L plus 2 or 2 into 2L plus 1. Therefore, substitute L equal to 3 for F sub shell. So 4 into 3 plus 2. Therefore, total 14 electrons. 14 electrons are possible. Option B. So maximum number of electrons that can be present in any subshell can be calculated by using 4L plus 2. So L value 3 for F subshell, 4 into 3 plus 2. 12 plus 2, 14 electrons. 4F subshell can accommodate maximum of 14 electrons. That means 7 orbitals will be present. Each orbital capacity 2 electrons, therefore 7 orbitals, 14 electrons. Option B. Next question. The number of radial nodes, angular nodes of 4F orbital. For 4F orbital, radial nodes equal to n minus L minus 1. N is 4. So for F, L equal to 3. 3 minus 1, that is 0. Next, angular nodes. Angular nodes equal to L. L is 3. Radial nodes 0. Angular nodes 3. So option A, 0, 3. Next question. Which orbital among the following has 0 radial nodes and 2 angular nodes? So 0 radial nodes and 2 angular nodes. So if we take 3D subshell or 3D orbital, radial nodes equal to n minus L minus 1. So n is 3. And for D, L equal to 2. 2 minus 1. That is 3 minus 3, 0. Next. Angular nodes, or we can say nodal planes. Equal to L. L value is 2. Therefore, option will be B. 3D. The 3D orbital, radial nodes 0 and angular nodes are nodal planes, L equal to 2. So for any starting orbital, radial nodes will be 0. That means S orbital starts at first orbit, therefore for 1s, radial node 0. P orbital starts at second orbit, therefore for 2p, radial nodes equal to 0. D orbital starts at third level, therefore for 3d, radial nodes will be 0. Next, F subshell or F orbital starts at fourth level. That means for 4f, radial nodes will be 0. Next question. The masses of electron, proton and a neutron respectively will be in the ratio. So we know mass of electron will be 1 by 1837 to that of mass of proton, and mass of electron is 1 by 1840 to that of mass of neutron. So from this we can write mass of proton is 1837 times that of mass of electron. Similarly, mass of neutron is 1840 to that of mass of electron. So therefore, mass of electron is to mass of proton is to mass of neutron will be equal to, so 1 is to, if mass of electron is 1, then mass of proton becomes 1837 and this one 1840. This will be the answer. So approximately 1836.15, approximately 1838.68. Therefore, option A. Simple ratio between subatomic particles or fundamental particles. Next one. The spectrum of helium is expected to be similar to that of helium. Helium contains 2 electrons. Here Li plus contains 2 electrons. H contain only 1 electron, single electron species. Sodium totally contains 11 electrons, atomic number 11. He plus contain only 1 electron. The atoms or ions with the same number of electrons will be having similar spectrum. Therefore, helium and Li plus will be having similar spectrum. Therefore, option A. Same number of electrons. Spectrum of helium is similar to that of Li plus ion. So, due to the same number of electrons. Next, if binding energy of electrons in a metal is 250 kilojoules per mole, what should be threshold frequency of striking photons in order to free an electron from metal surface? Very, very important model. Here what is given? So here binding energy is given. So binding energy you can take it as work function W. 250 kilo means 10 cube joules per mole for 1 mole. 1 mole of electrons, binding energy will be 250 into 10 cube joules. Next, we know work function equal to h nu naught. Work function or threshold energy. She is given 250 into 10 cube joules per mole for 1 mole. Therefore, nu naught equal to 250 into 10 cube joules per mole divided by h value, we know 6.625 into 10 power minus 34 joule into second. We'll get this value as 37.7 into 10 power 37 second inverse per mole for 1 mole of electrons. But they are asking for 1 electron. Therefore, nu naught equal to 37.7 into 10 power 37 by 6.022 into 10 power 23, which is Avogadro's constant. This value 6.26 into 10 power 14 second inverse for 1 electron. This will be the answer. For 1 electron, we must calculate. We should calculate. So answer will be 6.26 into 10 power 14 second inverse. So binding energy for 1 mole of electrons is given. We should calculate the threshold frequency for 1 electron. That means we have to divide that value with Avogadro's constant, which is 6.022 into 10 power 23. Next one. Theoretical question. Assertion. Energy of orbital decreases with increase of n. So energy of any orbital can be calculated. Energy of orbital or subshell equal to n plus L. We know this. So as the n value increases, energy also increases. But here it is given energy of orbital decreases with increase of n. Therefore, assertion is wrong. Next, reason. Energy is required in shifting away the negatively charged electron from positively charged nucleus. This statement will be correct. We know charge of nucleus is positive, charge of electron is negative. Therefore, so much amount of energy is required to separate electron from nucleus. So therefore, assertion wrong and reason correct. Therefore, D. Theoretical question only. As the value of n increases, energy increases. Next, some amount of energy is required to separate electron from positively charged nucleus. Reason is correct. Next one. This is also simple statement only. No two electrons in an atom can have the same set of all the 4 quantum numbers. This is the principle of Pauli's exclusion principle. So what is the meaning of this statement? Any atomic orbital can accommodate maximum of 2 electrons with opposite spins. So which is clearly Pauli's exclusion principle. This gives information about maximum capacity of each atomic orbital. An atomic orbital contains only 2 electrons with opposite spins. Say this is atomic orbital. Maximum capacity of each orbital will be 2. So for this electron plus half and for this electron minus half. You can take any atomic orbital can accommodate maximum of 2 electrons with opposite spins. That is the conclusion given by Pauli's exclusion. Exclusion means here only. An atomic orbital can accommodate maximum of 2 electrons. Only 2 electrons with opposite spins. Next. Calculate wave number and frequency of orange radiation having wavelength 6300 angstrom units. So here given wavelength lambda 6300 angstrom units, that is 6300 into 10 power minus 10 meters. You know 1 angstrom unit equal to 10 power minus 10 meters or 10 power minus 8 centimeters conversion. So here first we must calculate wave number. Wave number is nu bar. Nu bar is 1 by lambda. That is 1 by lambda value. So we can write 63 into 10 power minus 8 meter inverse. So which is 0.0158 into 10 power 8 meter inverse. Simplified value 1.58 into 10 power 6 meters inverse. Next one more. Frequency nu equal to C by lambda. You know C value 3 into 10 power 8 meters per second by wavelength 63 into 10 power minus 8 meters. Meters gets cancelled. You get this value 0.047 into 10 power 16 second inverse or 4.7 into 10 power 14 second inverse. So these two values are matching with 1.58 into 10 power 6 meter inverse, 4.7 into 10 power 14 second inverse. Option C. This question is related to electromagnetic radiation characteristics. Finding frequency, next wave number, energy, wavelength sometimes. Here wavelength is given. We are finding wave, that is frequency and wave number. Wave number is reciprocal of wavelength. Next one. If kinetic energy of an electron of mass 9 into 10 power minus 31 kg is 2 into 10 power minus 25 joules, the wavelength of electron in nanometers is approximately. Very important. So here kinetic energy is given. Kinetic energy 2 into 10 power minus 25 joules. Next, mass of electron 9 into 10 power minus 31 kg SI units. So we know according to de Broglie's relation, lambda equal to h by root 2m into Ke, where K is kinetic energy. H value 6.625 into 10 power minus 34 by root over 2 into mass of electron 9 into 10 power minus 31 into kinetic energy 2 into 10 power minus 25. We'll get this value as 1.104 into 10 power minus 6 meters SI units. So here conversion 1104 into 10 power minus 9 meters. So 10 power minus 9 meters means you can write 1104 nanometers approximately. So option C. Relation between kinetic energy and wavelength. Next question. The energies of an electron in first orbit of He plus and third orbit of Li2 plus in joules are respectively. You know energy expression, energy of electron in nth orbit or energy of nth orbit. So minus 2.18 into 10 power minus 18 into Z square by N square joules per atom. This is the expression for calculation of energy of nth orbit. So for He plus given values are Z value 2 and N value first orbit N equal to 1. So therefore N equal to minus E1. So minus 2.18 into 10 power minus 18 into Z square 4. So which is given by minus 8.72 into 10 power minus 18 joules. Next for Li2 plus Z is 3 and N value third orbit N equal to 3. Therefore E3 third orbit minus 2.18 into 10 power minus 18 into Z square by N square, that is 3 square 9 by 9. So which is minus 2.18 into 10 power minus 18 joules. So here clearly option A. Remember here energy expression, energy of nth orbit. Next question. This is based on quantum mechanical model. So wave functions of 1s orbitals of two hydrogen atoms psi A and psi B. So psi A and psi B are linearly combined to form two molecular orbitals sigma and sigma star. Which of the following statements are correct? So here how to form sigma. Sigma will be formed by addition overlapping of psi A and psi B. Addition overlapping or constructive overlapping. Star will be formed by subtractive or destructive overlapping of psi A and psi B. So this is addition overlapping, subtraction overlapping. So these two are molecular orbitals. The molecular orbital which will be formed by addition or constructive overlapping of atomic orbitals is bonding molecular orbital, and it will be anti-bonding molecular orbital. So when compared to anti-bonding, bonding will be having lower energy. Lower energy, and this will be higher energy. Addition overlapping or constructive overlapping of atomic orbitals will give bonding molecular orbital. Destructive or subtractive overlapping of atomic orbitals will give anti-bonding molecular orbitals. So when compared to anti-bonding, bonding will be having lower amount of energy. See here statements. First statement, sigma star is equal to psi a minus psi b, which is correct. Next, second, in sigma orbital, one nodal plane is present in between two nuclei. In sigma orbital, there will be no nodal planes or nodes. Therefore, incorrect. Third, energy of sigma orbital lower than that of sigma star. Sigma orbital means bonding, sigma star anti-bonding. Therefore, this one also correct. Therefore, options 1 and 3. There will be no nodal plane for sigma orbital. I will explain with one example. If you take 1s orbital of 1s orbitals of two hydrogen atoms. So 1s means spherical, plus here 1s also spherical. Here two types of combinations, additive overlapping and subtractive overlapping. So additive overlapping, I am writing here plus and plus. Additive overlapping will give bigger orbital. This is bonding molecular orbital. Say this is sigma, linear combination. Next, anti-bonding. Plus and minus. Here there will be nodal plane. Anti-bonding molecular orbital, which is sigma star. Remember these two. So sigma star has one nodal plane in between two nuclei. Nodal plane means the plane at which probability of finding electron is 0. Next one. The energy of an electron in an orbit of hydrogen-like ion with an orbit radius of 52.9 picometers in joules is. Ground state energy of hydrogen atom is given. So here radius of nth orbit we know 0.529 into n square by z angstrom units, or we can say 52.9 into n square by z picometers. Just conversion. 0.529 angstrom units, 52.9 picometers. Next, given value. Given radius 52.9 picometers. So equate these two. So 52.9 into n square by z equal to 52.9, which is n square equal to z. We got this expression. Z equal to n square. Next, what is energy expression? Energy of nth orbit equal to energy of ground state into z square by n square. Remember this relation. Energy of nth orbit equal to energy of first orbit into z square by n square. Z is atomic number, n is orbit number. Next, from this we have energy of nth orbit equal to energy of ground state. In place of z we can write n square, that is simply n power 4 by n square, which is E naught into n square. So from this we can calculate energy. So if n equal to 1, I am substituting values for first orbit. If n equal to 1, E1 equal to minus 2.18 into 10 power minus 18 joules. If n equal to 2, E2 equal to minus 2.18 into 10 power minus 18 into n square. N square means 4, which is equal to minus 8.72 into 10 power minus 18 joules. We have this value in options. So if n equal to 1, that option is not present in options. E2. E2 means if n equal to 2, we got E2 minus 8.72 into 10 power minus 18 joules. It is present in given options. Therefore, option C. Radius to energy calculation. Important model. Next question. The energy and radius of electron present in second orbit of He plus respectively are. So for He plus, atomic number equal to 2 and second orbit n equal to 2. Next, what is energy? We know energy expression En equal to minus 2.18 into 10 power minus 18 into Z square by N square joules per atom. Then substitute values minus 2.18 into 10 power minus 18 into Z square 4 by N square 4. So which is minus 2.18 into 10 power minus 18 joules. Next, radius of nth orbit 52.9 into n square by z picometers. 52.9. That means 52.9 into n square. N square is 4 by z2. That is into 2. Therefore, 105.8 picometers. So this is energy and radius. So option will be D. Minus 2.18 into 10 power minus 18 joules, 105.8 picometers. Remember these two expressions. Energy expression as well as radius of nth orbit. Next question. Which of the following sets of quantum numbers is correct for an electron in 3D orbital? So given 3D orbital. So for 3D orbital, n value equal to 3. N value 3. And the L values 0 to n minus 1. That is 0, 1, 2. Next, m values. If L equal to 0, m value 0. If L equal to 1, m can take values minus 1, 0, plus 1. If L equal to 2, m can take values minus 2, minus 1, 0, plus 1 and plus 2. So check these values in options. See here option C. N equal to 3 possible. L equal to 2 possible. M is minus 2 possible and S spin quantum plus half possible. Check in option A. N is 3 possible. L equal to 2 possible. M equal to minus 3 not possible. In option B. N equal to 3 possible. L equal to 3 not possible. L equal to 3 means F subshell. Here given D orbital or D subshell. Next, D option. N equal to 3 possible. L equal to 2 possible. M equal to minus 3 not possible. In this way we can check which configuration is possible and which configuration is not possible. So thank you very much. So next video we'll use some model questions of atomic structure. So all the best and thank you.